Good evening. It is good to be here and to see everybody. Raise that up just a little bit. We're in an ongoing study of elders and deacons, but as I mentioned one of the Sundays last month, I do want once a month to take a break from that if we need to, and to be able to get in one of these lessons covering science in the Bible. Don't usually do this on Sunday night, but I have a handout. I don't know how many there are left. I hope I printed enough. But Billy said if you raise your hand, if you don't have one, he will be happy to bring you one. I'll give you mine, Chris. Nah, I'm good. I got the filled out version. Yeah, I got the teacher's key. If we run out, I may have to. Paisley and Austin said they'd give their copy up, right? Why you look at me like that, Austin? We're looking in this particular lesson at astronomy. Some of these verses I'll mention, and I'll try to make sure to let you know. But you guys know, the Bremen folks know, I tend to quote from the King James version. It's the version I've memorized the most verses from. But a lot of these verses I'll use tonight are from the New King James. Sometimes I like that wording. And I'll try to let you know. Genesis 1:14 through 16, this is coming from the New King James. Then God said, "Let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons and for days and years. And let them be for lights in the firmament of the heavens to give light on the earth." And it was so. Then God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also. So the Bible tells us that God made the sun, God made the moon, and He made the stars also. There's a lot of information out there. I hope in this lesson just to whet your appetite. There's so much more that could be said. But it is so faith-building to study really all of these subjects that we'll look at, but astronomy is one of my favorites because you talk about showing, we sometimes sing, I remember singing several times with our children, maybe at a VBS or something like that, a song, "My God is so big, so strong, and so mighty, there's nothing my God cannot do." If you want to see just how big and mighty our God is, you study astronomy. And you want to feel small. Sometimes we get to thinking we're somebody. We even use the expression sometimes, maybe somebody got too big for their britches. But you want to realize just how small we are in comparison to the grand scheme of all of creation. Just study a little bit in astronomy. I've said this before when studying something like this. I'll say it again. I make no claims to being anything even remotely close to being an expert. I'm like those commercials. Are you a doctor or whatever? No, but I play one on TV. Well, I've been blessed to sit at the feet of some very learned men, and also to read from some very educated and learned men. A lot of what, especially in this particular lesson, a lot of what I draw on comes from, I can't even remember what year it was, but it was the West Georgia, Carrollton, I forget that it's Carrollton now, the Carrollton Church of Christ, their youth day. And it usually is in January. We had it, like a week or so ago? Usually it's in January, but that one particular year there was snow and ice or something like that, and so they had to cancel it, and it got rescheduled. It just so happened it got rescheduled weekend, so basically nearly every single one of our youth who might otherwise have gone missed it. And the man there that presented those lessons was Noby Stone. He'd worked for years with NASA. He's was or is, I'm not sure if he still is, at At that time, he was still doing some contract work for NASA, even though he was kind of semi-retired. But he was a rocket scientist. I mean, literally, just very fascinating fellow PhD. And so in fact, he even shared some slides with me that are in the presentation. But what is astronomy? I guess that would be our first thing to get into and define, sort of define the terms. As we often do, we look at the dictionary.com definition, or just what we sometimes just refer to in general, the dictionary definition. Astronomy is the science that deals with the material universe beyond the Earth's atmosphere. It's from a couple of Greek words, aster, or astron, star, and nomos, law. So it's the law of stars, and looking at some of that. And it's interesting because the word itself implies there's some law there. And there's arrangement, there's order, and of course, law necessitates a lawgiver. I've mentioned, I think I mentioned it last month in the very first lesson. As I said, I'm drawing on some of Noby Stone's material and other material as well, but a lot of, probably the majority of each one of these lessons comes from Wayne Jackson's Science in the Bible, or I think it's actually called The Bible and Science. But he makes the point in that book, in the chapter on astronomy, that the U.S. Constitution didn't write itself. A law necessitates a lawgiver. If there's a law, someone wrote the law, someone came up with the law, someone gave the law, so on and so forth. So there's that tells us something right there. The Greeks called the universe cosmos, means orderly or arranged. And we've talked about before when you're studying biblical modesty, there's a word that when it's translated modesty, such as 1 Timothy 2, it's a Greek word, kosmios or kosmios. And it's rooted in, its etymology goes back to this cosmos, orderly or arranged. But again, you see design, it's being hinted at there. The Greeks understood there's design. Originally, this study of astronomy was very much steeped in superstition. Some people still are that way today. They rush to the newspaper or whatever it may be, the internet, and they want to see what their sign is and what's going to be their horoscope for today or whatever. Well, all that is superstitious, and it's also based in paganism. But more recent time, astronomy has gained a great deal of respectability, but also has unfortunately become laden with a lot of evolutionary baggage. But when you study astronomy, it is hard to come away not realizing and believing in an all-powerful creator, because it could not simply have just happened. So that takes us to the next point here. Having sort of, at least in a general way, defined what is astronomy, let's talk about the origin of the stars, the planets, and so on. They either began naturally or supernaturally. There is no other option. And that, it's sometimes, we sometimes say, you oversimplify things, whatever, but really it is that simple. The universe, matter, period, began either naturally or supernaturally. It either happened somehow on its own or it was created. There's just no other choice. And that's just the way it is. Some suggest some type of a big bang. And of course, scientists are divided as to what, even the scientists that believe that it happened naturally, they're divided as to the main cause, but one of the more popular theories is some type of big bang. And they even have this idea of, some type of, it was just this very condensed, some scientists use the term a cosmic egg, and it's funny because Brother Jackson in his book mentions, they still have yet to locate the chicken from which this cosmic egg came. But, it's just very, very condensed, microscopic cosmic egg. that, at some point just explodes. But you got some problems with that if you want to take that position. For one thing, accident just is not adequate to explain an ordered system. And listen to me, well, you don't need me to tell you, I don't think. It is a very, very orderly system. It's not just random chaos. We may look up at the stars and think, wow, they're just scattered everywhere, like somebody just kind of threw them up there. But, it's very, very orderly, and we'll talk about that a little bit more later on. So accident is not really an adequate cause for that. Remember the law of cause and effect? Every effect must have not just a cause, it must have an adequate cause. Accident's not really going to be adequate or sufficient. Our universe is spectacular, orderly. Again, we mentioned that word cosmos, and its order is inherent within that. The universe is brilliantly designed, regulated, and we've used the illustration before. In fact, we've been studying some of this on Wednesday nights in our auditorium class, but if you go to a printing factory and set off a bomb, do you think there is any chance that you will come away from that explosion? Out of that explosion will come an unabridged dictionary. That's about the equivalent of what you're talking about, saying an accident, a big bang, a big explosion left us with this universe. But now, Chad, listen, we're going to do it over and over and over. We're going to set that bomb off in the printing factory, and if we do it 1,000,000 times, 1,000,000 times 1,000,000, 1,000,000 times 10 million, over and over and over, you're still not going to get it, right? We know that. We're not so naive as to think that could ever produce a dictionary. Unabridged or even abridged, right? It's just not going to happen. We know better than that. And even if, here's the thing, just for a moment, even if that could happen, you still set that explosion off in that printing factory, and that begs the question, who set off that explosion? What about the raw materials? So even with this idea of a big bang, well, who initiated that? Where did that material, even if you get down to this microscopic cosmic egg, if they want to call it that, where did the egg come from? You still have to have an origin for that raw material. Likewise, I think it's Brother Jackson in his book, talked about, if you set off an explosion in a lumber yard, could you expect from that you would get a fully built modern house? You could do it 1,000,000 times. You could do it 10 million times 10 million, and you will never get order out of such a situation. So you don't have an adequate cause if you say there's this big bang. Number two problem with that is that explosions do not produce order. Explosions propel objects radially. We've all seen, whether it's on television, maybe you've even set off some kind of explosion. It may just be in the form of a firecracker or something like that. But we understand explosions don't produce order. In fact, depending on how big of an explosion, it can produce quite a bit of disorder. But as I got on the slide here, set off a firecracker. See if you achieve order. I don't recommend that, young folks, without adult supervision, but you know what's going to happen there. Our planets, our solar system, our universe, they all display delicate order, delicate balance. And order argues for design. Not accident, not chance, not randomness. Order argues for design over and over and over. So, that being said, let's talk about astronomy and design. You know Psalm 19:1, the heavens declare the glory of God, and the firmament showeth his handiwork. paraphrase, we could just say the universe screams to us, there is a God. Well, what about it? The vastness of space is a testimony to the power of God. Just the sheer vastness of space tells us that there is a God. The number of heavenly bodies within the universe is just absolutely beyond imagination. It's beyond comprehension. Scientists, they once tried to number them. One of the latest estimates is something like over 100 septillion. I'm told this is a 1 followed by 26 zeros. I think that might have been one of the figures Dr. Stone, Noby Stone gave us at the Carrollton Youth Day. But a 1 followed by 26 zeros, 100 septillion. That's just kind of throwing a number out there. Albert Einstein suggested the totality of space could be as much as 100,000 times greater than just what we know, or knew at least during his time. The Bible says that the stars are numberless. Passages such as Genesis 15:5, God speaking to Abraham, he says, look now toward heaven, count the stars. If you're able to number them, so shall your descendants be. Jeremiah 33:22, these are coming from the New King James, by the way. As the host of heaven cannot be numbered, nor the sand of the sea measured, so will I multiply the descendants of David my servant and the Levites who minister to me. Hebrews 11:12, therefore from one man, and him as good as dead, were born as many as the stars of the sky in multitude, innumerable as the sand which is by the seashore. But here's the thing, it's mentioned there on the slide, God knows them by name. Psalm 147:4, also from the New King James Version, he counts the number of the stars. He calls them all by name. There's this, and scientists will tell you they sometimes will put these, kind of generic guesses or what we might call a ballpark figure. They'll sometimes throw those out there. Well, we estimate there may be as many as this many billion or trillion or whatever stars. But they don't know. Virtually impossible to number them. Yet God knows them all by their name. Isn't that amazing? Just think about just a few slides, pictures that some of these I found on Google Images and such, and some of these again come from Dr. Stone. But to just show you the vastness of this universe. And really, this is one of those things that it never ceases to amaze me. So, here you have Mercury, Mars, Venus, and the Earth. Top 4 planets there. And then dropping down here to image number 2, when you get to going beyond that a little bit more, you got down here, very bottom left, now Earth up here seems pretty large compared to Mercury, Mars, and Venus. But you get down here and it's that tiny little ball compared to Neptune, Uranus, Saturn, and Jupiter. Just absolutely dwarfed. But as they say, we were sort of laughing about this Wednesday night, the old Billy Mays commercials, when he would go, but wait, there's more. Well, there's more. The sun, let's talk about that for just a moment. The sun, of course, dwarfs any of our planets, right, in our solar system. These next few images, I do remember for sure, come from Brother Stone. This is a solar prominence, and you see the approximate size of Earth in comparison. That thing would just swallow up the entire Earth. And the sun, he tells us, and scientists have learned, is just basically one enormous, ongoing nuclear fusion reaction. Just amazing. It's just an ongoing nuclear reaction. At the core of the sun, it's about 27 million degrees. That's Fahrenheit. You get out to the outer edge, you see that bright spot there. Somewhere around 1 million degrees, starts to cool off considerably, if you want to call that cool. And then these darker spots, you have approximately 20,000 to 30,000 degrees. But amazing heat, just an ongoing nuclear reaction. But sometimes these reactions occur and it results in these arcs like that, these solar prominences. Sometimes you will get what we refer to, maybe you've heard of a solar flare, something like that. Again, you can see if Earth, of course, Earth is 93 million miles away, but if it were close by, something like that happened, it would just, be swallowed up. These things are enormous because of the sun's enormity compared to the Earth. But just amazing imagery, and I believe all these images that he shared, that he was generous enough to share with me, if I'm not mistaken, I believe they all come from the Hubble telescope. Just amazing pictures that we've gotten over the years from the Hubble Space Telescope. Sometimes you have just basically like more violent explosions. In fact, I remember very well him describing, talking about the sun. He said the sun's a very violent place. Again, it's just an ongoing nuclear reaction. Sometimes you have these very massive reactions that happen, and so sometimes you have one of the largest, this coronal mass ejection. But getting back to the vastness of the universe. So, you remember, we looked at the Earth in comparison to Mars, Venus, Mercury. Then we looked at the Earth and how small it is in comparison to Jupiter, say, and so on. Well, now, here you have Jupiter, this little tiny ball. And the star Wolf 359, you have our sun from our solar system. But maybe you've heard of the star Sirius. Sirius makes our sun look just like a little guy. But wait, there's more. Because you go from there, here is Sirius over here, this little ball. Now you have Pollux, Arcturus, Aldebaran. You see how, it's just mind-boggling. These make our sun look just like, our sun basically at this point would be pretty much just a pixel on this picture. But there's more. Here's that, remember Aldebaran over here? Here he is now in comparison to some other stars. There he is, just tiny, tiny little ball there. Regal, Betelgeuse, Antares. Isn't that amazing? The vastness of our universe. That is just mind-boggling. But then you even have more. You see these other stars, and here's Antares in comparison to them. The vastness of this universe is just nothing short of staggering. And here's a separate picture where you could just compare some of these that maybe are more familiar to us. But I don't know if you folks in the back can see it or not, but there is, right here is SOL, Sol. That would be what we call our sun. I don't know, it looks to me like maybe just a single pixel in that picture. And you see Sirius. Remember how big Sirius was in comparison to our sun? And then you go to Arcturus, Pollux, Regal, Aldebaran, this Betelgeuse, Antares. It's just it staggers the imagination. Just the vastness, the sheer vastness of our universe. Antares actually is visible with the naked eye at night in the constellation Scorpius. And, I've never been very good at picking out constellations. Maybe some of you are, but if you ever look up and pick out the constellation Scorpius. By the way, they have these apps now, and you can actually do this in an app. I don't know if I had mine readily available to tell you. I don't. I thought I might have it somewhere on here easily accessible. I could tell you the name of it, but Nikki Leonard is the one that put me onto it. She loves astronomy and stargazing. But you can actually, and there's a free version. That's what I have. And you point that thing toward the sky, and it will show you constellations if you're looking at one. And it may even be daytime, and you can see these things. And you can just pan that thing around, and it'll tell you, Saturn, different planets and things like that, and it's pretty fascinating. Well, I wish I had thought about that before the lesson. I could have looked it up and told you what it's called, but Anyway, I'm sure there are multiple apps that'll do that, but pretty fascinating. But Antares, you could actually see it with the naked eye. It's part of this constellation Scorpius. I believe that's the meaning of Antares, is heart of the scorpion or something like that. And you see it's kind of at the where they say that the heart of a scorpion is. But here's our sun from our solar system. Radius of approximately 0.005 AU. We'll talk about the AU in just a second. The orbit of Earth, the entire orbit of Earth is 1.0 AU. That's astronomical unit. Again, we'll talk about it in a second. 93 million miles. The orbit of Mars, 1.5 astronomical units. The radius of Antares is about 2 astronomical units. So, diameter, Noah would be, I know Noah hates math. It's 4, I think. I'm not that great at math either, Noah. But it would be 4 astronomical units, right? I just say that because here's our solar system, right? With our, added the little dot there just to clarify, our sun, and you see several of the planets. If you took that star, Antares, and you could just throw it onto our solar system, right smack dab in the middle where the sun is, that's the center point, it would look something like this. You've eaten up 185 million miles. You just swallowed up, I don't know, what was it, 4 or 5 planets there. A great 1, 2, 3, 4, 4 planets just swallowed up. That's how big that star is. And there are so many others that we don't even know about. I mentioned the astronomical unit. You see, the Earth is 93 million miles from the sun, so they've called this an astronomical unit. That's 1 astronomical unit. When you get out into some of these measurements out in the vastness of space and deep space, they have to come up with different units because miles really aren't sufficient. And of course, we'll talk about light years in just a second as well. But here's an illustration that Dr. Stone gave at the Carrollton Youth Day, and to me, it just made it really drove home kind of some of the vastness. Traveling 100 miles per hour in a vehicle, nonstop, beginning the moment you were born. If you had some kind of a vehicle that you could just, boom, you head out, the moment you're born, you're going 100 miles per hour when you arrived at the sun. You would be 106 years old. That's traveling nonstop, 100 miles per hour, 24/7. You'd be 106 years old by the time you got. That's just to our sun. All those other stars, they're even further out. That's just to our sun. And yet, to help put that in perspective as well, Antares that we were just talking about is 4 times that distance in diameter. So you would be, I need Bob, I think 424 years old. Is that right? Some of you math folks, 424 years old by the time you got to cross the distance of the diameter of the star Antares. That's just, it's mind-boggling. Again, the speed of light, 282 miles per second. And so again, you have to start measuring things in the speed of light because the vastness of space. But light travels 7.5 times around the Earth in 1 second. Pretty amazing in itself, right? But even traveling at the speed of light, 186,000 plus miles per second, it takes light about 8.3 minutes just to get to Earth. To travel that. That's how long that distance is, even traveling at the speed of light. To travel across the entire solar system at the speed of light would still take you 10 days, going nonstop. That's just our solar system, by the way. You see why we say astronomy, that study tells us just how big our God is? And it helps us understand how relatively small we are in the grand scheme of things. A light year is, of course, the distance light travels in 1 year. 6 times 10 to the 12 is 6 million miles. I believe that figure came from Dr. Stone as well. But you get the idea here with these just vast numbers. Some of these things, the death of stars, even stars, they're ongoing nuclear reactions, but eventually even a nuclear reaction, it's got to have fuel, right? Eventually it runs out, and so this is a Hubble Space Telescope picture of a star that is dying, and you see the radiation being given off as it's dying out. It's just beautiful images, but yet also just absolutely awe-inspiring. Here's a galaxy. I believe it's a galaxy that I was trying to remember. I thought I had another. I may have left off. I had some more information on there, I thought. But anyways, it's turned on its side, because if you were just looking straight up at this, you wouldn't see anything. It'd just be black. But turned on its side, you can actually see this. Again, I think it's a galaxy. Here's a picture of the Andromeda Galaxy. Again, this one came from Dr. Stone. It's about 2.3 million light years away. This is the closest spiral galaxy to our Milky Way, but it's still 2.3 million light years away. Again, that's the light years distance. Light travels in an entire year. Light can go to the sun in 8 minutes, a little over 8 minutes. We're talking the distance it travels in a year, 2.3 million light years. It's mind-boggling. Southern Pinwheel Galaxy here. This one is 15 million light years from Earth. Beautiful pictures coming from the Hubble Space Telescope. Here's a real creative one, a real creative name, the Sombrero Galaxy. Some scientists saw that and thought it looked kind of like a sombrero, so they called it the Sombrero Galaxy. But that's 33 million light years away. Amazing, amazing stuff. And here, this one, I love this one he shared. I kind of called it When Worlds Collide. These are technically galaxies, but just unimaginable energy here. 80 to 100 billion stars each, but you see the one over here on the left, it is the greater, and it is just pulling in, its gravitational force is just pulling in this other. But those are two galaxies that have collided, one just being swallowed up essentially by the other. It's just fascinating stuff. And then this picture, I love this picture. The most distant galaxies here are located some 13.2 billion light years from Earth. And you look at that, and it looks kind of like, maybe even similar to when you look up at the sky on a nice clear night. You can see a bunch of stars. But did you know there's not a star in that picture? There's not a single star in this picture. You know what those are? Those are galaxies. Every little dot you see is a galaxy. They took this with the Hubble telescope. They left it on sort of he explained it, I think it was something similar to like a time lapse or maybe something like that. But they began to look at it, and at first they didn't see anything, and then they would see these, they started putting it together again, kind of something similar to a time lapse. And there are all these little dots, and then they began to realize these are galaxies, just unimaginable vastness in our universe. And so the vastness of space is absolutely a testimony to the power of God. But not only that, the organization of the universe is a testimony to the power of God, but primarily here, the intelligence of our God, the creator of all things. Earth, again, is the third planet from the sun. It's about 93 million miles away. It spins on its axis at about 1,000 miles per hour at the equator. It orbits the sun at an average speed of 66,600 miles per hour. That's about 595 million miles in its yearly orbit. I worked really hard to memorize all those. No, I didn't. I got there's a reason we write these things down, right? But it was fascinating, by the way, if any of you were, Ethan, were you guys there that Saturday? It was just fascinating. I mean, he could just, no notes, nothing. I mean, he just rattles that stuff off, and just a very, very, very intelligent man. But here's my question. What started this movement? The Earth orbits the sun. We all understand that. We've known that for years, 93 million miles away. But what started that movement? Who started that movement? You know, or at least are familiar with the concept, Newton's first law of motion. An object at rest tends to stay at rest. And an object in motion tends to stay in motion. Something had to initiate that movement, folks. There has to be what we sometimes refer to as a prime mover. And the Bible calls that prime mover God or Jehovah. Just look at Earth itself, and it tells us there's a creator. But we could talk about the delicate balance of the Earth's orbit around the sun. We talked about the Earth that orbits around the sun. What started that movement? Let's talk about that orbit, the delicate balance of it. There is centrifugal force that is pushing outward. And we've used the illustration before of you may take something and you start to whirl it around, and you may tie a string around something, a rock or something, and you start to whirl it, and the more you whirl it, the more that thing wants to just come loose. And if you're not tied very well, especially if it's got any weight or mass to it, you're going to, pretty good chance you're going to lose it, because that centrifugal force begins to pull it outward. And so that, as the Earth orbits, centrifugal force wants to just push it off out into space, right? So why doesn't it? Well, because at the same time, gravity from the sun and just the sheer mass of the sun, we saw that compared to the Earth, is pulling back on the Earth. Now, isn't that something that just happened? This big explosion, and the Earth is now rotating around the sun, which tends to make it want to just float off out into space. But there is gravitational pull from the sun that holds it just right, and so there it goes, and it's in that orbit, and there it stays. I don't know about you, but I'm not buying that that's just chance. The strength of gravity that holds the Earth in orbit is equivalent, they say, to a steel cable, at least 8,000 miles in diameter. The amazing balance between the gravity and the centrifugal force can only be explained by intelligent design. You can't explain that by accident, folks. If we tried to tell somebody that today, that we had something that was just so perfectly aligned, such perfect precision, who made that? Somebody might say, nobody. It just happened. It just walked in here one day and it happened. I think maybe one night when I went home for the day, an explosion went off in the office and I came in the next day and there it was. Nobody would buy that. What about the mathematical orthodoxy of the universe? As the Earth orbits the sun, it has to make minute adjustments to conform to its elliptical track. And it digresses from a straight line 1/9 of an inch every 18 miles. I mean, really, Chad, are you serious? Will you sit here and talk about 1/9 of an inch? Well, that's important because if it was only 1/10 of an inch, well, the Earth would gradually move out further and further toward space and would become uninhabitable because basically all of us would freeze to death. If it was only 1/8 of an inch, Earth would gradually be pulled little by little closer to the sun, and eventually it would be uninhabitable because it would be too hot, and we would all eventually die due to those conditions. It's just right. Even the alterations to the orbit are just right. Just a chance. The mathematical precision of the universe allows precise prediction of eclipses. Remember just a few years ago, the eclipse that was predicted the exact time. Oh, here, if you're here in the country, here's your time. If you're over there in the country, here's what time it'll be. And it was. Just a lucky guess by scientists? No, it's because the universe is so precise. Targeting of satellites. We can launch satellites and even rockets to the moon and land them just right on a specific spot because of the mathematical orthodoxy. I've mentioned before when I was at GBN, it's now Encompass, but Crawford Communications is what they were called at the time. They sent us just as a customer this, it's like a poster basically, but it shows, it's like a look at the horizon of the Earth and all the satellites that are up there, and they're just dots. And I mean, it looked like somebody just been dot, hundreds of them at any given time. And yet they're not colliding. How on earth do we pull that off? Mathematical orthodoxy in the universe. They can have it so that those things sometimes they'll just come right beside each other and not collide. Because they know the mathematical precision and orthodoxy. There's something I've read this to you before, but prior to 1846, Neptune, the planet Neptune, was unknown to astronomers. But in the early 1800s, there were two scientists. They were working independently, by the way. And they both figured out, they surmised that there was gravitational pull of some unknown planet that was having a great effect on the planet Uranus. So they just began working it out on paper with mathematical calculations, and each one of them, again, independently, predicted. They didn't have the telescopes to be able to see it. They didn't have the technology to be able to see it, but they said, essentially, accommodatively speaking, like, if here's the planet Uranus, right here, there's got to be another planet because of that gravitational pull. There's something there, whether it's a planet or some kind of celestial body, something is there. Well, in 1846, they discovered the planet Neptune. It was right there where they knew it was going to be. Mathematical orthodoxy of the universe. Astronomy, it screams to us, God is. But what about the purpose of heavenly luminaries? This is kind of a shorter point, but what we understand, we live on Earth. Earth is just right for, it's the only planet inhabitable. It's the only planet that sustains life. What's the purpose of all these other systems, stars, galaxies? Is God just showing off, or what is it? Well, there are a number of purposes that we could give, but just a few. They are to give light. We saw that in Genesis 1:14-15, to give light, to divide the day and the night, signs, seasons, days, years. We saw that again right there in Genesis chapter 1. But also they serve as a navigational tool. In Acts 27:20, remember they were traveling in that great storm, and Paul says that it had been numerous days and they had not seen sun nor stars for many days. Well, that was critical because you needed those to navigate. They didn't have the navigational technology that we have now. Even if you don't see sun, stars, anything, it could just be completely cloud cover, but we can navigate now with modern technology, but they didn't have that. They needed the stars to navigate. But also spiritual lessons. Numerous times in Scripture that stars and astronomical things are used for spiritual lessons. Most of us from childhood learned about Joseph and his dream where the sun, the moon, and the stars bowed down, his mother, his father, and his brethren bowing down before him, and of course came to pass when he was in charge there in Egypt. Also, Numbers 24:17, again, New King James Version. He says, a star shall come out of Jacob, a scepter shall rise out of Israel. That's a messianic prophecy using astronomical things. Revelation 22:16, Jesus says, I'm the root and offspring of David, the bright and morning star. And Matthew 2, verses 2 and 9. Where is he who has been born King of the Jews? We have seen his star in the east and have come to worship him. When they heard the king, they departed. Verse 9 says, behold, the star which they had seen in the east went before them till it came and stood over where the young child was. So spiritual lessons. And then, in short, we could kind of sum it all up by saying God made them to declare his glory and for our benefit. Isn't it fascinating sometimes just to look at, even just, again, what briefly we've considered here tonight? But it just makes us stand in awe of the God of heaven. Truly, the heavens declare the glory of God, and the firmament shows his handiwork. Listen to Romans 1:20. You're probably familiar with it, where he says, "For the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." We have evidence of God's existence all around us. We have his word, and we are truly without excuse. And so as we wrap our thoughts up here this evening, I was about to forget this quote from Wernher von Braun. Dr. Stone mentioned Dr. von Braun. He's the reason we have NASA, pretty much, his research and his efforts. But he said this, "Speaking for myself, I can only say that the grandeur of the cosmos serves only to confirm my belief in the certainty of a creator. The universe revealed through scientific inquiry is the living witness that God has indeed been at work." It's from Dr. von Braun, October 1976. In fact, if you go to Huntsville and you go to the Space Center there, it's called, or at least there's an area there called the Wernher von Braun Space Center. So he's just monumental research. But as we close out our thoughts, as we've said so many times before, if there is a God, and the evidence is there that there is, then he is real. He's communicated to us, and it's amazing to think that the God who made all these things, and we are so small in comparison, and yet these things don't tell us about God. They just tell us God is. But he wants us to know about him. He wants us to be his people, to be his children. And so that's why he's communicated to us through Scripture. And so as we always do, we want to close with an invitation. Maybe you are not a child of God. Maybe you need to obey the gospel of Christ. Or you might not be where you need to be spiritually, and maybe you need prayers for strength, for encouragement. I like something that Brother Jeff Archie said yesterday in our Men's Day, which was excellent. But he made a point. He said, the Lord's invitation, it's always open. And sometimes it may be that people are shy. It may be that people are having a hard time getting out of something. But don't ever think that the Lord's invitation ends just because service ends or the sermon ends. As long as we're alive and able and have breath and the mental capacity, we can respond. Maybe you want to know more about the God of heaven who made the galaxies and all things. Let me know. Let somebody here know. We want to sit down. We want to talk about that. Maybe you want to know more about how to become his child. And say, I don't know. I'm shy about coming forward or whatever. That's fine. Let us know somehow. But make sure you know the God of heaven. And make sure that you have rendered obedience to his gospel plan of salvation so that you have hope beyond this life. And if we can help you with that now in some way, that's why we sing this song to encourage you. Why don't we stand and sing?